Over the past 2 decades, jellyfish have begun to overwhelm our oceans. In New Zealand, divers swat off millions of stinging jellyfish, each no larger than a grain of pepper. In Sweden, a massive cluster of moon jellyfish shut down one of the world's largest nuclear reactors by clogging the plant's essential pipes. In the Sea of Japan, thousands of 200-kilogram numerous jellyfish, which build 2 meters in diameter, swarm fishermen, snapping nets and devouring local fish. Around the world, these animals voraciously consume fish eggs and larvae, routinely undermine marine farming efforts, and outcompeting adult fish and by consuming the resources they need to survive. If things stay on their current trajectory, we could be headed for a future where entire ocean is thick with jellyfish. So, is there anything that can keep these gelatinous creatures under control? Enter a humble sea turtle. There are a wide range of marine animals that feed on jellyfish, but sea turtles are among the most ancient predators, while every known species of sea turtles prey on jellyfish at some point in their lives. None consumes quite as many as a leatherback. Leatherback are the largest species of sea turtles, and they eat jellyfish almost exclusively, devouring well over 1,000 metric tons of them over their roughly 50 years lifespans. This is particularly remarkable because jellyfish are 95% water and very low in calories. So to maintain healthy weight, the average 500 kilogram leatherback needs to eat roughly 400 kilograms of jellyfish every day. That's roughly the same weight as a grand piano. And while some sea turtle species have been documented selectively eating the prey's protein-rich gonads, leatherback eats jellyfish whole, mowing down huge swaths of unsuspecting jellies. Normally, jellyfish aren't quite this defenseless. Most species have tentacles covered in cells called nightcytes, which contain venomous harpoons coiled and ready to launch. These barbed structures, known as nematocysts, are released on contact. Jellyfish frequently use this sting to paralyze and kill their food, and it can also irritate the skin of would-be intruders. But it's completely useless against sea turtles. Most of these reptiles have thick scales covered in keratin, the same material that makes up nails and clothes. This leathery armor protects their skin while they hunt, and any captured prey that tries to escape is impaled on the keratinized spikes lining the leatherback's esophagus. For most sea turtles, these adaptations make individual jellyfish easy prey. However, a jellyfish population true defense mechanism is how quickly they can reproduce. Almost all jellyfish species have evolved to reproduce both sexually and asexually, allowing them to increase the numbers with or without partners. In tropical environments, jellyfish reproduce constantly throughout the year, but in more temperate climates, species often reproduce all at once in a massive bloom, where jellies multiply at alarming rates. And humanity is making these blooms much more frequent. Fertilizer runoff from farms introduce chemicals that simultaneously kill other fish and prompt blooms. High water temperature caused by climate change speed up jellyfish reproduction, extend the reproduction season. Meanwhile, both marine construction and pollution dramatically increase the surface area for jellyfish polyps to attach, grow, and mature. All these issues require a wide range of policy-based solutions. But one major way to prevent jellyfish population from getting out of hand is to protect their natural predators, many of whom are currently under threat. Small-scale fisheries that are essential to communities in Mexico and Peru often use gillnets, which unintentionally capture and kill hundreds of sea turtles each year. In the Eastern Pacific, these practices could drive the razorback to extinction in the next 60 years. Fortunately, some researchers have already developed inexpensive tools to minimize these risks. Attaching green LED lights to gillnets have proven useful for allowing sea turtles, dolphins, and even seabirds to avoid fishing gear. Solutions like this should allow small-scale fishers to support their communities while minimizing their impact on the leisurely ocean defenders.